How do inverse operations work in algebra? Have you ever wondered how we can solve equations so easily? The secret lies in something called inverse operations. These are pairs of actions that reverse each other, making it possible to isolate variables in algebra. Let's break it down. The most common pairs of inverse operations are addition and subtraction, as well as multiplication and division. When you add a number and then subtract the same number, you return to your original value. For instance, if you add 5 and then subtract 5, you are back where you started. Similarly, if you multiply a number and then divide by the same number, you also return to the original number. For example, multiplying by 3 and then dividing by 3 cancels out the effect. These operations are essential when solving equations. Consider the equation where a variable is added to 4, like x plus 4 equals 9. To isolate the variable, you subtract 4 from both sides. This reverses the addition, leading to x equals 5. Now let's look at multiplication. If you have 3 times x equals 12, you can divide both sides by 3 to reverse the multiplication. This gives you equals 4. When equations have multiple operations, you apply inverse operations in the reverse order of how they were originally applied. For example, if you have 4 times x minus 3 equals 13, you first add 3 to both sides to undo the subtraction. Then, you divide by 4 to reverse the multiplication, isolating x. There are also specific properties related to inverse operations that are helpful. The additive inverse of any number is negative x, because x plus negative x equals 0. The multiplicative inverse of any non-zero number is 1 divided by x, since x times 1 divided by equals 1. Understanding these properties aids in simplifying and solving algebraic expressions and equations. In the context of linear relationships and linear equations, inverse operations are particularly useful. They allow you to solve 4 unknown variables by systematically reversing the operations applied. This process makes complex problems more manageable by breaking them down into simple steps. Practical applications include solving 4 variables in formulas, balancing equations, and understanding how changes in one quantity affect another in a linear relationship. By mastering inverse operations, learners gain a foundational tool that supports further study in algebra and beyond. So, the next time you tackle an equation, remember the power of inverse operations. They are your best friends in the world of algebra.